Welcome with our new lesson 7.4 Inverse Variation. Our lesson objective is to solve application problems involving inverse variation. We studied in the past lesson how to solve application problems involving direct variation, and we saw that we have two variables which are having a relation between them. We called it direct variation. And these variables, if they were, for example, x and y, when x increases, y also increases. And if x decreases, y also decreases. But in this lesson, today, we are dealing with two variables having a relation. We call it inverse variation. So that if x increases, y decreases. And if x decreases, y increases. And such a relation, we can write the relation between the change in x and y to be like this: x1 times y1 is equal to x2 times y2. And this is the relation which we are going to use to solve our problems which are involving an inverse variation. There is some applications on this relation. One of these applications is the polysystem relationship. This is what we call the polysystem relationship. We have two pulleys connected together. So a large one turns in a speed which we call it RPM, number of rounds per minute. And it turns a smaller pulley which also has its speed in RPM. Each pulley has a different size in diameter. So the relationship here is between the diameter of the pulley and its speed, which we measure it by rounds per minute. So as you can see, pulley A is the small pulley. The diameter of pulley A, if it is multiplied by the RPM of pulley A, this will equal the diameter of pulley B times the RPM of pulley B. So we will use this relation to solve applications on this relationship. Let us see an example on this. Looking to the picture in front of you, you can see two pulleys connected together. Pulley A has a diameter of 15 centimeters. So D1 is equal to 15 centimeters and has a speed of 300 round per minute. Pulley B has a diameter of 24 centimeters, and we want to find the speed of the large pulley. Since this relationship is an inverse variation, so we can say that 15 times 300 must equal to 24 times x. So we want to find this x, which is the speed of the large pulley. So x is going to be equal to 15 times 300 divided by 24. And this is going to be 187.5 RPM. We have another application on this inverse variation, it is the gear system relationship. And as you can see in this picture, we are having two gears connected together. One of them is moving the other one. Gear A and gear B, they are different in the size. They are different in number of teeth for each of them. And also they are different in the speed, which we say rounds per minute for each of them. Also here, we can apply the inverse variation on this relationship. So, number of teeth in A times the RPM of A is equal to number of teeth in B times the RPM of B. Let us see an example on this application. Looking to this picture in front of you, you can see two gears connected together, and gear A, it has 25 teeth and a speed of 300 RPM. The small gear has 18 teeth, but the speed is unknown and we want to find it. So we can say that number of teeth for gear A multiplied by the RPM of gear A must be equal to number of teeth for B times RPM of gear B. Let us substitute numbers in this relation. So we can say that 25 multiplied by 300 is going to be equal to 18 multiplied by x. So x, which is the speed of the small gear, is equal to 25 times 300 over 18, which is going to be equal to 416.6 RPM. We have a third application here on this relationship, and this relationship we call it the lever relationship. One of its applications, as you can see in this picture, this man tries to move or to lift this large stone. So he uses a relationship applying the inverse variation. If we multiply the distance between the man and the fulcrum, which we call it here in the picture D2, and the force that the man is pushing, which we call F2, this will be equal to the multiplication of the distance between the rock and the fulcrum times the force that is applied with the large stone. Let us see an example on this relationship. As we can see in this picture, we have a lever relationship here. So the large force F1 is equal to 72 pounds, and the distance D1 is equal to 3 meters. But looking to the other side, the force, the small force, is unknown, and the distance is equal to 8 meters. As if the question is asking, how much force should I apply on F2 so that I can lift the other side, which has 72 pounds? To solve this question, we apply the inverse variation. So we will say that F1 times D1 is equal to F2 times D2. So 72 times 3 is equal to 8x. So x is equal to 72 times 3 divided by 8. And this is equal to 27 pounds. So we need to apply 27 pounds on the side of lever we call F2, so we can lift the other side, which is 72 pounds. By this, we reach the end of our lesson. Thank you.